Okay, we're looking at laws of logarithms. And the laws of logarithms state that if you have a common base, you can write the sum of a logarithm as a product and product as a sum. So it means log base a of a times b can be written as log base a of a plus log base a of b. These are very useful to us, especially in calculus. If it's dividing, you subtract. So log base a of a minus log base a of b. And in this situation, if you have something to a power, you can dump it out front so that it becomes c times the log base a of a. So let's look at the direction. It says use the laws of logarithms to rewrite the expression in a form of no logarithm of a product, quotient, root, or power. So here we just simply write as log. We're going to use our first rule, which is this one right here. And it's a product. We're going to write it now as a sum. So log of 5 plus log of 3. And that's it. This one we will have the log of 3 plus the log of 4 squared plus the log of 5 to the 6th. So we've separated the multiplication, and now we will dump those out front. Log of 3 plus 2 log of 4 plus 6 log of 5. And we're done. The next one, we'll move the 3 out. 3 log of 4 over 7. And now we'll use our subtraction. 3 times the log of 4 minus the log of 7. If you wanted to write that 3 to each one as 3 log of 4 minus 3 log of 7, that would be fine. Now it's time to talk just a little bit about what's going on here. First of all, as you can see that this is 4 over 7 to the third power, both the 4 and the 7 are being taken to the third power. That's why in your final answer, the 3 is attached to both of these. Second of all, just note that 4 is in the numerator. So it has positive value for an exponent. 7 is in the denominator. It has negative value for an exponent. So notice how this is positive, this is negative. We'll deal with that more in a little bit. This situation we rewrite as log base 3 of x squared minus 5 to the 1/2 power. We can dump that 1/2 out front. 1/2 log base 3 of x squared minus 5. So now that I have that, some people want to separate this x squared minus 5. Well, you can't. You can't separate this subtraction. You can only separate the product and the quotient. You can't dump this 2 out front either because the 5 and the x are not being squared as a product. So that does not work either. Natural log, things don't change, but I want you to consider what's happening here. This is a little bit more involved problem. These are in the numerators up here, so these are going to end up positive, and this is in the denominator, so it's going to end up negative. So I'm going to write as the natural log of 2x to the 4th, and then minus the natural log of x minus 2 cubed. Notice now that you can separate this with multiplication. Some people want to pull the 4 out front. Well, you can't because the 2 is not being taken to the 4th power. It's just the x. So first we must separate the 2 and the x to the 4th. So natural log of 2 plus natural log of x to the 4th minus the natural log of x minus 2 cubed. Now I can dump the 4 out and I can dump the 3 out. And I have the natural log of 2 minus 4 natural log of x minus 3 natural log of x minus 2. And that's that. And for the last one, we have the natural log of 4x squared over 2yz raised to the 1/3 power. Again, these are in the numerator, so they'll end up positive. These are in the denominator, so they're going to end up negative. First thing, I can dump the 1/3 out. Get 1/3 times the natural log of 4x squared over 2yz. Now I can go ahead and divide, or rewrite my division using subtraction. 1/3 times the natural log of 4x squared minus 1/3 times the natural log of 2yz. Notice how I carried the 1/3 to each one because each one was being taken to the 1/3 power. I have to separate both of those. 1/3 natural log of 4 plus 1/3 natural log of x squared minus 1/3 natural log of 2 minus 1/3 natural log of y minus 1/3 natural log of z. So notice how all those are negative because they were all in the denominator. Finally, let's bring our exponent out front. So we have 1/3 natural log of 4 plus 2/3 natural log of x minus 1/3 natural log of 2 minus 1/3 natural log of y minus 1/3 natural log of z. And there we have it. So that was a little bit more involved. Let's try to go the other way. They are multiple logarithms. Let's write them as a single. This becomes log base 2 of, I can multiply the 5 and the 7 to get 35. And that's it. This one, I'm going to rewrite it as 2 log base 5 of 3 minus 1/3 log base 5 of 64. So dividing by 3 is the same as multiplying by 1/3. I'm going to bring these up to the exponents. What is 3 squared? It is 9. Minus, what is 64 to the 1/3 power, or the cubed root of 64? It is 4. Now, I have the subtraction, so I can write it using division. Log base 5 of 9 over 4. I don't like that. Log base 5 of 9 over 4. That looks better. Ooh, the next one. Let's see. Positive, so it'll be in the numerator. Negative, denominator. Positive, numerator. Let's keep that in mind. 2 natural log of 4 will be, I'm going to move the 2 up, so I get natural log of 16. Move the 3 up, and so I get minus the natural log of 2 to the 3rd, which is 8. And then plus the natural log of, move the 1/2 up there, I get the root of 2. Now, just understand in terms of addition and subtraction, this is the same as natural log of 16 plus the natural log of the root of 2 minus the natural log of 8. Okay, so addition is commutative, so I can move it all around. See then how these end up in the numerator? I have the natural log of 16 roots of 2 over 8, which is the natural log of 2 roots of 2. So I'm going to deal with the parentheses on the inside first, then we'll deal with this 3 in the end. 3 times the natural log of x plus 1 times x plus 2. If the 2 goes up here, I have a y squared, and it's minus, will be divided by y squared. And now I can put the 3 up here. So the natural log of this thing, x plus 1 times x plus 2 over y squared, and we're taking that to the 3rd power. We're not cubing the natural log, we're cubing everything inside of that. And if you wanted to write it instead of There's multiple ways of doing this. You want to write it like instead of that, you want to go 3 and 3, and then this was 6 down here. That would be fine too. So, all right. Let's use the properties of logarithms to evaluate these expressions. Log base 2 of the root of 32. So log base 2 of 32 to the 1/2 power. Notice we could drop this 1/2 out front. So 1/2 times the log base 2 of 32. Well, what is the log base 2 of 32? That means 2 to what power is 32? 2 to the 5th power is 32. So I get 1/2 times 5, which is 5 over 2. Okay, the next one, we're going to rewrite it. We'll have it log base 5 of, this is subtraction, so I'll go to division, 100 divided by 4, which is the log base 5 of 25. That means 5 to what power is 25? Well, that would be 2. Log base 3 of 27 to the 4th. So I'm going to drop that 4 out there. So 3 log base 3 of 27. Whoop, I put a, should be a 4 out there, excuse me. Sorry about that. To try to teach us something we're going to learn next year, I'm going to change this a little bit more. 4 log base 3 of 3 cubed. Remember that these are inverse operations. They go away. So after 4 times 3 is 12. Just like this one here, e to the 3 times the natural log of, oh, I don't know what happened there. It didn't print off for me. Let me check. Hold on. Sorry, sometimes things get lost in the print process. It's supposed to be a 5 right there. So e, and that would be to the natural log of, you drop the 3 up here, and 5 to the 3rd is 125. And remember that these are inverse operations of each other, so you get 125. All right, last thing we need to talk about is the change of base formula. So this reads 6 to what power is equal to 14? Well, I know 6 to the 1st is 6, and I know 6 to the 2nd is 36. So if I'm looking to get 14, then my answer has to be somewhere between 1 and 2. How do we do that? Well, the problem is that your calculator, it doesn't have a base of 6, and it doesn't have a base, or it doesn't have a base of 6. It's only got a base of 10. So if you hit logarithm, that's a base of 10. So like the log of 14, get 1.1. That's not our answer. And if you hit natural log of 14, you get, let's see, 2.63. That's not your answer. The way that we determine this is you do the log of 14 over the log of 6. So you do the log of that divided by the log of that. Or you could do the natural log of 14 divided by the natural log of 6. So like in this case, our base is 10, and in this case below, our base is e. So it doesn't matter which one you choose. I'll show you how it works, okay? Log of 14 divided by log of 6. And you can see you get 1.47288. So we should really go to 3 decimal places for sure, 1.473. And then we'll try the natural log. Natural log of 14 divided by the natural log of 6. And we get 1.473 again. If we actually try that, 6 raised to the 1.473, you can see that you get about 14. You would have to carry it on a long ways in order to get that. So look at this one, log base 7 of 2. That means 7 to what power is 2? Well, 7 to the 1 is 7, so I know it's got to be less than 1. We do the log of 2, and we divide it by the log of 7. Log of 2 divided by the log of 7. And I get 0.356. And then the last one means 14 to what power is equal to 1,652. I have no idea. But what we do is we do the log of 1652 divided by the log of 14. And if you want to use natural log, you can. It doesn't matter. So as long as you do the same thing. Natural log 1652 divided by the natural log of 14. And you can see that I get 2.808. And there you have it, folks. There is your laws of logarithms and your change of base formula. Good luck.